everyone. So we will be discussing some questions on memories. So memories is a topic from electronics only, digital circuits. So let's just move on to the question. This is a very small topic, so only few questions we will be discussing about this topic only. So okay, so this is the first question. So first question says that addressing of a 32K cross 16 memory is realized using a single decoder, right? So we are using a 32K by 16 memory, right? The minimum number of AND gate required for the decoder. So minimum number of AND gates. So how we are addressing the memory? So it is 32K cross 16. So how we actually address the memory in general way? So that is 2 raised to power n cross n, right? Now minimum number of AND gate, minimum number of AND gate required is nothing but equal to 2 raised to power n. Here options are there in terms of 2 raised to power. So we cannot directly write 32K, right? So we have to convert this 32K into 2 raised to power n. So very easy, 1K is 2 raised to power 10. Now 32K will be equal to 2 raised to power, now 2 raised to power 5 is 32, right? 2 raised to power 5 dot 2 raised to power 10. So 2 raised to power 15. So 2 raised to power 15 AND gates will be required. So option C will be your correct option. Right, very easy question. This is how we represent the memory, and the question is asking that how many number of AND gates. So minimum number of AND gate is nothing but 2 raised to power n. Okay, so next question. Next question is really big, but the solution is very small. The question is saying that a 2 by 2 ROM array. So the 2 by 2 ROM array is given like this. A very small part of ROM, 2 by 2 ROM array is given, and it is a diode ROM only. So this is a diode ROM. In diode ROM, when diodes are connected, we have to take that one, take that bit. Otherwise, we have to consider that other bit is 0. Right? A 2 by 2 ROM array is built with the help of diodes as shown in the figure, right? Where here W0 and W1 are the signals that select the word line. So here these are the word line selectors, right? And B0 and B1 are the signal that are the output of the sense. So these are the output of the sense amplifiers, right? So W0 and W1 are the input, and B0 and B1 are the output, right? Based on the stored data corresponding to the bit lines during the read operation. Okay, nothing to worry about this question. Now the question is asking that during the read operation, the select word goes high and the other word. So whenever we are doing the read operation, what is happening if we are selecting the read operation on omega or W0? So W0 we will consider it, and other one will go in high impedance state. That means we should just ignore that, right? Other word line goes into high, or other word goes into high impedance state, right? As per the implementation shown in the figure, right? What bit corresponding to Dij? So we have to just fill out the matrix. So nothing to worry about this matrix. So what is it saying? So suppose I am considering W0 is equals to active. So when we are taking W0 word line, right? So in this case, when W0 is equals to 1, then B0 will be 1, because B0 is connected to W0 in this case, and B1 will be equal to 0. And if we are taking W1 be equal to 1, that means if we are selecting W0 for the read operation, then in this case the output B0 will be equal to 1 and B1 will be equal to 0, because diode is connected to B0 in W0. And similarly, if we are considering W1 for the read operation, then what's happening? Then B0 will be 0 because there is no diode, and B1 will be equal to 1. So if we can easily place this into matrix. So when W1 and B1, for W0 and B1 B0, that will be 1, and for this it will be 0. For W1 and B0 it will be 0, and W1 and B1 it will be 1. So this will be the matrix. Option A will be your correct option in this case. So when diode is connected like this, right, so that means in this case, even if you consider the MOSFET part, when diode is connected directly to D01, so what happened? It goes to high state, so it will be 1, and here there is no connection, so it will be grounded, so it will be 0. And similarly for W1, it will be connected to 1 and it will be grounded. So that's why we can put bits 0 and 1. Right. Next question. Next question. In a DRAM, that is the dynamic RAM. So there are options given and we have to just choose one option. Periodic refreshing is not required. So it is not true for DRAM. In dynamic RAM, so DRAM is made up of capacitors. So we have to periodically refresh them in order to keep the data keep the data or in order to keep the data as it is periodically. So DRAM is made up of capacitors, so we have to periodically refresh them. So first option is not correct. So we have to. Now, second, information is stored in the capacitor. That's true for DRAM. Information is exactly stored in the capacitor. Information is stored in latch. No, information is stored in the capacitor. So for DRAM, information is stored in the capacitors and we have to periodically refresh them in order to maintain the data or in order to maintain the information. Okay, next. Moving on to the next question. The question says that in the circuit shown in the figure A, so this is your figure A, and parallel in a parallel out 4-bit register is given. So A is your parallel in parallel out register. Parallel in and parallel out. So that means it is taking the inputs parallelly and giving the outputs parallelly. Right? 4-bit, so 4-bit input data is coming parallelly and 4-bit output data is getting out parallelly. Right? Which loads at the rising edge. So this is driven by this clock C. This is the clock C and the data is loaded inside this parallel in parallel out at rising edge. So this is the rising edge, this is the rising edge, and this is the rising edges. Right, now next it is saying that the input lines are connected to a 4-bit bus W. So this is the input lines. So I have made it little wrong. So this is the input. So input line is connected. So this is the input, right? This is your bus W and input lines of this parallel in parallel out is connected to the bus W, and the output acts as at the now the output of this parallel in parallel out acts as the input. So this is the input to the ROM. The ROM is 16 cross 4 ROM whose output is floating when enable E is 0. Right. So now the output of the ROM will be there inside the bus when enable will be equal to 0. The partial table of the content of the ROM is given. So now the content of the ROM is given to us, right? What is this? This is a setup of a little tiny microprocessor type. So what is saying that a parallel and parallel out register is there, and the input of the parallel and parallel out register is connected to the bus, and the output is given to the ROM. Now, output of the ROM is connected to the bus, right? And this table is given in which address and the data of the ROM is given to us. Now question is saying that the clock to the register is shown. So this is the clock that is given to us and the data on the bus at time t1. So at time t1 the data is given. So now the data inside the bus is 0, 1, 1 and 0. The data in the bus at time t2. So now this is first clock, right? At t1 time, I know that data will be equal to this. Data will be equal to 0, 1, 1 and 0. 0, 1 and 0. 0, 1 and 0 will be equal to 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 0, 1, 1 and 0. They are asking me what will be the data inside the bus at time t2. Now this data will act like an address to the ROM, right? It will go inside the PIPO, that is parallel and parallel out, and it will act like the address to the ROM. So data will be, this value is equals to nothing but 6. Now this 6 will address 6 and the data inside that address will be 1010, right? At T1 this is happening. So this is the data inside the bus. Now it will act like an address to ROM and the output of the ROM will become 1010 because this will become address and address value 6, we have the data 1010, right? Now what will happen? Again at T2 rising edge, the PIPO inputs will be given to the ROM. Now what will happen? Now this, the data inside the address, that is 1010, it will act like the address to the next data, right? So this is the address, 1010 is nothing but 10. So now this will be the new address and the data inside it will be the data inside the bus. Get my point? At T1 what is happening? The data is floating inside this bus which is equals to 0110. That is equals to 6 or decimal 6, and that will be the address to the new data. So that will be the address to the new data, and the new data inside the address 6 which is equals to 10 and 10. Now this is happening in this T1 cycle. Now what is happening in T2 cycle? Now at T2 cycle this 1010 will become the new address because it is now stored in this PIPO and it will be given to the input of ROM. Now it will be the address. So 1010 address will be the input to the ROM. Now at this address which is equals to decimal 10, we have the data 1000. So now the output will be 1000. So data inside the bus at T2 will be equal to 1000. Which option is correct? So C option will be your correct option. This is how the memories work, right? The data inside the bus will become the address and we will get the next address from the data stored inside that address, particular address. So at T1 cycle, this was the address and this was the data. Now at T2 what will happen? This will become the address, this will become the address and this will become the data. Like this it will work. And this is for example for T3. For T3 this will become the address and 1000 in decimal will be 4. So this will become the address now and this will become the data for T3. This is for T1. This is for T2. This is how actually the memory work. Right. Next question. In next question, if the input x3, x2, x1, x0 to the ROM in the figure 8421 BCD number. So 8421 is our regular decimal to binary conversion, right? BCD number that output y3, y2, y1, y0 is. Now what is happening? We have a BCD to decimal decoder here. BCD number is binary decimal code, binary coded decimal, right? So we have BCD to decimal decoders. Now we have proper denote, D1 up to D9 and they are connected to ROM like this. So they are asking that if we are having a connectivity like this, what will be the output? Y3, Y2, Y1 and Y0. So in order to find out this, we have to make the truth table. So how we will be drawing the truth table? So I'm drawing it here only. So for x3, x3, x2, x1, x0, y3, y2, y1 and y0. How we will be getting the output? So for 0, 0, 0, 0, if the values of x3, x2, x1, so if this is 0, 0, 0, 0, 0, so this is decimal 0 only. So this is, I am writing the decimal value here. So this is decimal 0 only. For decimal 0, the value of y3 is equals to 0 and y2 is equals to 0. This is equals to 0. Where does it cross? That value is 1. Where there is no cross dot, that value is 0. So it will be again 0, 0, 0. 0, 0, 0, 0. Now next, decimal value 1. 0, 0, 0 and 1. Now this is your D1. For this 0, 0, 0 and 1. 0, 0, 0 and 1. Similarly, we can go for 2, 0, 0, 1, 0 and here also 2 at y1. 0, 0, 1 and 0. Decimal value 3. So this is 2, 3, 4, 5, 6, 7. This is 8 and this is 9. Right. So for decimal value 3, 0 and for input I am writing first 0, 0, 1, 1. That will be the equivalent decimal value of BCD number and output will be equal to again 0, 0, 1 and 1. 0, 0, 1 and 1. Till now they are same, right? So we can just exclude few of the possibility. It cannot be gray code, it cannot be XS3, because XS3, if it would have been XS3 for 0, we would have we would have got the output as 3. For 1, the output will be 4. For 2, the output will be 5, like this. XS3 code works like this. So none of the above, we will check the possibility for this code. Okay. 4 is 1, 0, 0, 0. Right? This is the 4. Now 4 decimal is here. Oh, sorry, this is 8. So 4 is equals to 0, 1, 0, 0. So this is your BCD 4. Okay. Now 4 here is again same 1, 0, 1, 0, 0. 5. Now 5 for BCD number is 0, 1 and 0, 1. Here is again 0, 1, 0, 1, 0, 1, 0, 1. Now 6. 6 for this BCD number is equals to 0, 1, 1 and 0. So this is your 6. Now here 6 is equal to 1, 1, 0, 0. 1, 1, 0 and 0. Now there is some change. We will see that how this change is going to affect the answer. Now at 7. So 7 is 0, 1, 1, 1. And here output 7 is equals to 1, 1, 0, 1. 1, 1, 0 and 1. If I am talking about decimal 8 is equals to, in BCD is equals to 1, 0, 0, 0. Right? But here outputs are like 1, 1, 1 and 0. 1, 1, 1 and 0. And lastly 9 is this 1, 0, 0, 1 in BCD. But here it is 1, 1, 1, 1. Now this change start after this, after 5. So after 5 what happened? So this is BCD. But now if I write in 2421 codes. So in 2421 codes 6 is 1100 because 24, that will be 2 plus 4, that will be 6. 1100. And if we talk about 7, so 7 is 241. So that is your 7. And if we talk about 8, so 8 will be 242. So that will be 110. And if we talk about 9, so that will be 2421. That is correct. So this is nothing but 2421 BCD numbers. This type of coding is 2421. So whenever you are getting confused in digital, so what you do is best you just make the table. When you make the table, everything get clear, right? In this RAM, how we are in this ROM, how we are accessing. So this is how a typical ROM circuit diagram looks like. So whenever there is a cross, that means it's connected. That means it's connected. Whenever it is not cross, that means that particular part is not connected. That is not connected. So that will be giving you value 0. And whenever you see a cross, that will be equal to 1. Right. Next question. Right.